Okay, next lesson. Let's talk about the heat sequencer. Let's see what a real live heat sequencer. If you type heat sequencer into your search bar, you'll see all kinds of heat sequencers. The bottom tabs are the low voltage. The top tabs are the high voltage pass-throughs. The bottom is a load, and when you heat that up, basically the mechanical function is to pull a rod down that allows contacts to occur, and then you can run power through high voltage power. So again, we're looking at a device that works with low voltage on the bottom right here. This is your low voltage, and then high voltage passes through the other sections of it. And all this diagram here represents is basically two sequencers connected together. This is a single sequencer, this is a double sequencer. There's just a little conductor right there, little wire that connects them. A conductor is anything that's good at allowing the electrons to flow. So copper is a very good conductor, so is gold, so is platinum, so is silver. Even aluminum is a pretty decent conductor. But we use copper mostly for our wires, or aluminum. The only thing is with aluminum you need to gauge your wire size a little larger than with copper, because aluminum tends to expand and contract a lot more than copper. And when your conductor expands and contracts, it causes gaps, which leads to arcing, and arcing leads to fire. So a good conductor is anything that's good at allowing the electrons to flow. Now even things that are not good at allowing electrons to flow can still allow electrons to flow. So electricity still can pass through things that are not good conductors, but it likes to flow through things that are good conductors. And a good conductor, essentially, if you look at the atom and how it's broken down in shells, the outer shells of that electron has 3 or less electrons, and that would be called your valence electrons. That's the outer shell on the atom. We'll talk about those later maybe, but basically a good conductor is an atom where the electrons are encouraged or easily jump to other atoms, and that's the electron flow. And this is a lot of different pictures of heat sequencers. Some of them are tied together as doubles, some of them are singles. You can make your own double, you can make a triple. It's real easy to do. Back to the diagram. In the diagram I've got a double sequencer, and what the sequencer does, like the name sequence, it allows the power to pass through at different times, so you can kind of stage when your power comes on. Like this side might connect first. The top one will connect before the bottom one and allow power to pass through. It just stops everything from coming on instantly. It gives a little bit of time between the process. Again, the bottom tabs are your low voltage, and right now we're just working with the low voltage. Again, L1 to switch, switch to load, load back to L2. Your switch in this case is the thermostat, and we've got our power going into our thermostat with our red wire. Our yellow wire is for our cooling contactor. Our white wire, that's going to be this one, is going to be for the heat sequencer. And white wouldn't make a lot of sense to draw because it'd be difficult to see it against a white background, so I'm going to use blue. Blue is going to represent the white wire, and I'm going to run that over to there. So that would be a white wire, and then that's switch L1, then after the load back to L2, and L2 is right here. Now I can bring this wire back to the terminal, or I can bring it to any place on an existing wire that's going back to L2, and it's not interrupted by any switches. So I could grab this terminal here and I could jump it over to here, or I could tie into this conductor anywhere. I could peel back the insulation around the wire, and I could tie into it at any point. Doesn't matter where on this wire I grab onto, as long as this L2 makes it back to this spot right here, L2. L1 to switch, switch to load, load back to L2. And that is your heat sequencer. We're talking about the low voltage circuit, the 24 volts, and we have already hooked up our contactor. Now we've hooked up our heat sequencer, and in the next one we were going to hook up our fan relay. We'll show you a picture of that and how that thing works. And these are going to run our devices, and they are going to be represented by little fans and little light bulbs. So we are representing our condenser fan motor with the little fan. Our compressor is going to be represented by a little fan. Low heat and high heat are going to be your light bulbs, your indoor fan, low speed, and your indoor high speed fan. Just going to break it apart in separate fans. When I taught in school, we had some big panels. We had all of these devices hooked up to some wood panels. We had power running to them, and you would use wires, electrical jumpers, and you would jump all these different connections and make it work. And that was the class. And by the time you got done with that class, you could wire up this board and make it work, and you would have a good understanding of how an air conditioning system is wired up. And this is just the very basics involved in wiring up an air conditioner. But if you understand this, you pretty much understand how an air conditioner is wired up. And that concludes this lesson.